Dear colleagues and friends, good afternoon. First of all, I want to thank to organizers for the opportunity to present the presentation on behalf of expert group from Northern Arctic Federal University, located in the northwest part of Russian Federation, in the city of Arkhangelsk. Our presentation is dedicated to climate change impacts on the cultural and historic ensemble of Solovetsky Island. First of all, to better understanding of the significant importance of this cultural heritage object, I will briefly talk about the geographical position and historical development of the site. Solovetsky Island is an archipelago geographically located in the White Sea, consisting of 6 large islands: Большой Соловецкий, Анзер, Большая Муксалма, Малая Муксалма, Большой Заецкий, Малый Заецкий, and more than 100 small islands. The ancient development of Solovetsky Island is the White Sea started at the turn of the Mesolithic and Neolithic epochs, in the middle of the 5th century. On the islands of the White Sea were found and explored more than 70 primitive sites, workshops and locations, about 30 stone labyrinths, and more than 200 embankments and symbolic stone of different time and purpose. The archipelago has been the site of fervent monastic activity since the 15th century, and there are several churches dating from the 16th to the 19th century. The cultural and historic ensemble of the Solovetsky archipelago comprise a monastery fortress of 15th to the early 20th centuries, a former monastic village of the 16th to the early 20th centuries, cells and hermitages, insular hydraulic and irrigation systems, scarce sites and dozens of settlements of 6th to the 1st millennium, groups of memorial construction of the Solovetsky special prison camp, and the surrounding natural and cultural landscape. The heart of the historical and cultural complex of the archipelago is the architectural ensemble of the Solovetsky monastery, which is a holistic unicure architectural complex. Its constructions are characterized by the monumentally individuality and integrity of all components resulting from the centuries-old tradition of building. The Solovetsky historical and cultural complex is the only large set of monuments in northern latitudes, built from local boulders and combination with rare brick and iron produced in Solovetsky Islands. The peculiar linear design of the facade and high density of buildings on small areas contribute to the integrity and architectural expression of the ensemble. The fortress is the only Russian fortification complex built with the use of large boulders, which adds greatly to its individuality. Till 1992, cultural and historic ensemble of the Solovetsky Island is protected by UNESCO. The protection and preservation of cultural heritage sites, including immovable historical and cultural monuments made of stone, has become a pressing issue in recent decades. For instance, unpredictable weather conditions, rising sea level, coastline erosion and destruction, and increased natural diseases are consequences of climate change. It is known that brick and natural stone, such as limestone, marble, basalt, and others, were widely used as building and finishing materials in the construction of architectural sites. Their durability can be measured in hundreds and thousands of years. Depending on the climate zone of the structure, rocks aging under the influence of natural moisture, frost, wind, insulation, biodegradation, and groundwater salts may occur at different rates. However, the rate of negative processes has increased significantly in the last century due to the intensive human activity. The influence of anthropogenic factors on the conservation of stone structures has become comparable to the effect of natural diseases such as floods, sandstorms, and earthquakes. Climate change is one of the main contemporary challenges in the contents of cultural heritage site preservation. It is regarded the relevance of developing an integrated system for the sustainable management of architectural monuments preservation is obvious. In our opinion, an integrated preservation management system should consist of the following mandatory elements. For the first, comprehensive monitoring of environmental factors, natural and man-made. For the second, continuous monitoring of the current system state, wear and aging. For the third, risk and threat assessment, forecast of changes in the physical condition of the site. And for the fourth, development of adaptation measures aimed to preserve the site and assessment of their effectiveness. To establish the effect of global climatic process of the state of historical cultural monuments of Solovetsky Islands, a number of elements of the monastery complex were taken as subject of the study, namely Korozhная Tower, Predilная Tower, and Belaya Tower. The choice of these structures for the study was determined by their location and spatial orientation, which establish a distinct patterns in the prevailing wind direction that is critical in assessing the effect of climate parameters on the condition of the structural elements. The towers are round structures with four tiers located on hills. The walls of the towers are made of large boulders with the space between them filled with small boulders and lime mortar brickwork. The analysis of average monthly air temperature showed a positive linear trend, and the air temperature increased on average by 2.1 degrees Celsius. A positive linear trend was detected in the change of the average annual relative humidity. You can see increase in relative humidity in average by 10%. A positive linear trend was detected in the change of the average annual and maximum values of snow depth. You can see on this slide, snow depth increased by 2 centimeters and the maximum value of this parameter increased by 15 centimeters. Based on analysis of the hydrometeorological parameters of the White Sea, you can see the sea level has been gradually increasing with an average of 31 centimeters per year. It is correspond to average ground speeds of the world ocean level. You can see on this slide, for the past 20 years, the White Sea level has grown by about 6 centimeters. For the past 10-year period, you can see the wind direction gradually changes from north to east to southwest. And besides on this analysis of a significantly large body of data on the main climate indicators in the local territory of the Solovetsky Island, we can conclude that climate transformation is taking place in this territory due to the global process of climate change on the Earth. The next step of our study was a risk and threat assessment, forecast of changes in the physical condition of the site in connection with global climate change process. You can see on this slide the nature of the detected defects and damage for the first object, Korozhная Tower. You can see the photo and short description about this defect. On the next slide, you can see the detected defects and damage for the next object, Belaya Tower. You can see the photo and marked cracks and biological destruction elements. On the next slide, you can see the third object for our research, the Predilная Tower. You can see the detected defects and photo of damage. When comparing the climate data with the data from the technical inspection of the structures, it can be assumed that an increase in air temperature and humidity will intensify the deterioration process of the brick masonry and the biodegradation of the wooden element of these structures. The observed magnification of the destructive effect of thermal and humidity deformations is associated with the nature of the ongoing climate change. For example, growth in the amount of liquid and mixed precipitation in the cold climate season, an increase in the number of freeze-thaw cycles, and increased wetting of building walls followed by cooling. The available observational data are not indicative of a noticeable increase in wind loads. However, if the average wind speeds remain constant or change slightly, the probability distribution may transform due to the increased influence of wind gusts. In this regard, additional regional studies are required. Thus, due to the increased and extremely high air expect intensification of the combined effects of wind loads, thermal deformation, and corrosion. In this regard, the main practical recommendation and adaptation measures for the preservation of this site was developed, and you can see this measure on this slide. Dear colleagues, thank you for your attention. If you have any question, I try to answer on this. Thank you.